go. It's a what? X is a random variable with a density function. So we know density function. So hence, you should be thinking continuity, or continuous random variable. They tell us that this function, it has 0 to 1, 3x squared over 2 plus x, and then everywhere else is 0. If you want to check if it is a density function, if you integrated 0 to 1 of f of x, it should equal to what? 1. Very good, because it's a density function. So area under the curve must add up to 1. So that's one way to check if it is equal to 1, because if you did it, you would realize that there was something wrong with my equation, because it doesn't equal to 1. Okay? So now that we fixed it, we did a plus x to it. Let's have a look at this one. So to find expected value, for those who have forgotten from our previous lesson, that is the sum of x times the probability of x equals little x for chapter 13. So according to that theory, we can do the same for continuous. That's why it is probability of x equals x is actually the integration and then x times that. So let's work it out. 0, 1, x times, what's the function again? 3x squared over 2 plus x dx. I'll simplify it, but then you're doing the integration. So 3x cubed over 2 plus x squared dx. Go. I'm going to pause the video. Here we go. What's the integration of 3x cubed over 2 plus x squared? Can I please have, let's go with Joe. Joe. What does this become? Yeah, you definitely have x to the power 4. No, you're doing derivatives now. You bring it to the bottom. So the 4 goes to the bottom. So 2 times 4. 8 is on the bottom and the 3 stays there. Okay. So add the power by 1 and then times it by whatever the power is on the bottom. But what's the next one? X squared. Let's go with Adrian. What's antiderivative of x squared? X cubed over 3. Very good. Add the power by 1 and then divide by the power. Very good. Fundamental theorem of calculus. Or definite integral. Sub 1 in. And then take away sub 0 in. But you can already see if you sub 0 in, everything's going to cancel out. So it's really just sub 1 in. So if you sub 1 in, you're going to get 3 out of 8 plus 1 out of 3. Wait, something is a bit off. How come I got a different answer here? No, I did get the same answer. No, I got the same answer. What'd you guys get? 3/8 plus 1/3, which is, Serena? 17 on 24 is correct. Hands up if you got e to the x or e of x correct. Good, it's just a simple integration and fractions. Next one. So you know how to do e of x. How do you do e of x squared? I always get this every year that someone in the class does not know how to do that. It comes up in the exam all the time. So, how do you do it? So you know how to do e of x. It has just the letter x. And how do you do it when it's x squared? What would you do? Let's go with Alex. How do you do it when you've got e of x squared? So we've done e of x. How do you do it when it's x squared? Yeah, you sub in the x squared. That's it. This here, that x, instead of times it by x, you literally times it by x squared. Nothing else. Nothing trickier. If they did 3x, you sub 3x in. Okay, same idea. So here we go. It's x squared times, and you do the same thing again. 3x squared over 2 plus x delta x, and it's still between 0 and 1. I'm going to simplify it again, and then you calculate for me. So here we go. That should be 3x to the 4 over 2 plus x cubed dx. Go. Next bit, antiderive. Let's pick someone else. Xavier. What's the antiderivative of 3x to the 4 over 2? We haven't done that. That's all right. Albert. Haven't done that. Adrian. 3x to the power of 5. Good, just add the power by 1 and then divide it by that power. So 2 and the 5 becomes 10. Very good. Okay, so that's antiderivative, practicing antiderivatives. And then x cubed, antiderivative x cubed. We all should know that is? Good, x4 and 4. Beautiful. And the nice thing again, 0 and 1, zeros will cancel out. But if you sub 1 in, it's just itself. So it becomes 3 over 10 plus 1 over 4. Cross method it. And you should end up with 11 on 20. Hands up if you got E of x squared correct. Good, good, good. Excellent. Why did we find E of x squared? Because the question was asking, find the expected value and find the variance. This is the variance formula. Make sure to cross off that plus. There should be a takeaway. That's a takeaway there. Whoops. That should be a takeaway. So you found E of x squared. E of x squared was 11 on 20. Take away E of x, which we had 17 on 24. Squared. Now that squared bit, probably not in a exam. It'll probably, usually it's 9 on something, like 9 on 4 or something like that. It's something doable, but not that number. I would use a calculator at this point. What did I get? Oh, wow, that's a huge number. 1392880, which is approximately 0.048. I did a CAS, so unless I typed it wrong. Did you all get that too? Cool. So that's your variance. That's just practicing 15B. So you got expected, then you got your variance. Now this is where 15D comes in. 15D. Zoom in. Sorry, if you didn't copy it here, that's the answer for variance. You need the variance. Okay, 139 over 2,880. And it's approximately 0.048. Copy that down. And then we're going to do 15D today. So 15D is just applying that transformation. So here we go. 15D. So with this ornament, notice on the bottom they said the value of each ornament in dollars is given by 100 minus 1.5x. The question is, find the expected value not of x, but this time of v. Okay, so they want you to find the expected value v, which really just means sub that one in. What changes? This is now a linear function of a random variable x. And I gave you the two formulas above for E of ax plus b. What does that equal to? So you should be able to find the mean, and later you're going to find the standard deviation, which means you need the variance of ax plus b. So on your sheets, I already gave you the formula. But just to get you started, what is a and what is b in this scenario? Can I please have, let's go with Mia. What is a and b? Beautiful. Stick with the formula that I've given to you at the start of at the very top. And I want you to find me E of ax plus b. Let's go. So what would E of a, I'll rearrange it to make it easier for you visually. What would this equal to? And do the same for variance. So what's the variance of v? Or another way is to say variance of negative 1.5x plus 100. I've given you the formula. Pause the video. All right, let's check your answers. I'm going to write in the solutions I had. So it should be negative 1.5 times E of x, which you found was 17 on 24 before, plus 100. On my calculator, I ended up with 1583 over 16. Did you guys get that?
Yeah.
Okay, good. So I didn't type wrong. And that was approximately 98.93. Somewhere there. Variance version. You only need the dilation factor A, so it should be squared of negative 1.5 times the variance, which we calculated before, was 1392880. 1392880. Use exact values in your calculations. Only round at the end. What is that? I don't think I did this one. Negative 1.5 squared times 139 over 2880. 139 1280. What's that approximately? About 0.108. Roughly. Okay. All right, standard deviation. So that means now you know what the variance is. Standard deviation is the square root of whatever you just got. So square root of 139 over 1280. What'd you get? What is that? Did you guys get 0.3295? Good. So that is 15D, adding in that extra bit here. So that's one bit. Flip over the page. There is another bit of 15D that you need to know as well. 15D, transformations. Visually. There's a whole bunch of information there, but if you don't understand it, this is what I want you to remember. Have this as part of your bound reference, because I don't think it comes up in your formula sheet, maybe. Can you copy that down into your bound reference? I'm just going to put this as bound reference. What is this? In a nutshell, when you have a linear random variable, continuous, you're essentially changing the function f of x and you're transforming it somewhere else. But if you're transforming, listening? If you're transforming a function to another function, we can already read that there's a horizontal translation and there's a dilation. But one of the things you've got to be careful is if you dilate it, translating is fine, because if you move the distribution left and right and you change the intervals, it's still okay. The area will still be 1. The problem is that if you dilate it, if you pull it up in the same interval, that is going to be less or more, right? So this is one of the reasons why, notice that when there was a dilation here, we usually say it's dilation from the y-axis, which is here. Makes sense? But why is there also a dilation from the x-axis as well? It's because you've got to keep the area 1. Okay, to counteract that. So that's why you can see in this part here, the transformation, if you understand how the transformations work, there is a proof in your textbook if you want to look at it. Otherwise, all you have to understand is that A becomes 1 on A and there's 1 on A. That plus B, which usually means to the left or to the right, it's the opposite because we do the same in our chapter 7 transformations. Yeah. So from here, it's just about applying that. So if you didn't understand, just looking at the transformation of that is totally confusing. That bit that doesn't make sense to you, then just write that. That will be useful for you to use to solve that kind of problem. So let's have a look at this one. This example, using that information that A becomes the dilation 1 on A and also for the y and x. Yeah. Here's my problem. Let x be a random variable with a probability density function. So because they said probability density function, if you integrate it from -1 to 1 for this function, it should equal to 1. So let's test it. There we go. Let's define the function so I don't have to type it again. F of x is equal to 3/4 times, what's that, 1 minus x squared. Is that it? Yep. And I'm going to integrate it between -1 and 1 of f of x dx. Good. Probability density function equals 1, and technically it's quadratic. You can actually see that looks like a, 3/4. So 1 accepts 3 on 4 and minus x squared. So essentially it's just probably like this. 3/4. X-intercept is 1 and 1. There we go. That's roughly what the graph looks like. So if you sketch it on your CAS, that's what the graph looks like. And the area is 1. Okay, and everywhere else is 0. So, just with the graph makes it easier to answer the question. What's the range of the function? Because I sketched the graph for you there, but usually you'd have to do it yourself. What is the range in this case? Can I please have Samuel? What's the range? Good. Range must be between 0 to 3 on 4, based on the graph that I just drew. I just sketched the function. Now, what transformations? What's a transformation? So again, you can use what I've just given you up there to read the transformation. But what transformations do we have? What transformations do we have? Say that again. No, you are right. If we're stating in the order, so Dr. T, so there is, it's just that because that if you split it up, then it becomes a, you can split that up into x of a minus b of a. That could be, yeah. So yes, if you read the transformation, you got 2x minus 1. This is my a. That's my b. So according to that transformation, as you can see there, it is essentially saying 2x plus b, which is minus 1. And then you also have y over 2. So you can read that transformation in either way. In this case here, what are my transformations? So we had left by 1. We also have, is it left by 1 or is it? Did I write it wrong? Where's 2a? Oh, sorry. Yeah, that's minus b. Plus b. So when you move, yeah, you're right. Sorry, my bad. I just realized when it's plus b, remember it becomes that minus b over there. So we've got moving it to the right by 1. So moving to the right by 1? No, wait. It's x plus b, a plus b. It should be moving to the left by 1. Yeah, sorry, no, it's moving to the left by 1. Is it plus 1? Yeah, it's minus 1. No, to the right by 1. What am I talking about? Sorry. It's, as I just realized, this is the transformation that's there. Yeah. Let me just check what that graph looks like. Sorry, my bad. I'm pretty sure it should be 2x minus 1. All right, let's see. So we're doing factor of 2, so half times f of, what was it again? X was, okay, so it's x plus 1. Yeah, plus b over 2. Yeah, it does shift to the left by 1. Yeah, to the left by 1. Or 1 over 2 if you think of it that way. But I'm just following that transformation that we have over here. So if this is 2 and that was a minus 1, then that becomes plus 1. Yeah. Okay. So because it becomes a plus 1, then it's the other way around. So it goes to the left by 1. That's why it was a bit confusing for me there. Okay. So you can see what I just did there. I'm just going to rub this out so that you don't get confused. I just followed your ax plus b becoming 1 over a f of x plus b over 2. Right there. And so because we've got 2x minus 1, function becomes 1 over 2 f of x plus 1, or think of it as minus negative 1 over 2. You can see it from inspection, but you have to realize because they're trying to this formula comes from combating that change in the area. And because they combat that changes the way we normally do it. Because we're not wrong in the way we normally do it. It's just that is normally a translation to 1 over 2, but because you're inserting rearranging. So this is what you will substitute in. But if you read that, that's essentially reading it to the right. Yeah, it's a bit confusing. I get what you mean. Anyways, yeah, so the transformations, we can see it's going to the left by 1, dilation of factor 2. So we know that it is also a flat, like a compression, okay, factor half. And so now this makes the question, if you're changing the shape of this graph, that means the area, you still need it to be 1. But that also means that the domain has changed. So the original domain was between negative 1 and 1. So right now, if I go back to my CAS, if we did integration of this new transformation, if I did 1 over 2 of f of, what was it again? X plus 1, was it? Over 2? See, the problem is if I go from negative 1 to 1, you don't get 1. So we need to change the domain now. How do you work out the domain? Anyone have a clue? You find when the integral equals to 1, so you can trial and error, or? Very good. And this is your transformation. Right there. Oh, sorry, the transformation. So if you work it out now, you're essentially going from 2x, let's see, what do we get? You got from 1, we're timesing it to, what did I write? I wrote 2x minus 1, negative 1, add 1 both sides. What does that give you? That's 2. Wait, did I do something wrong there? Sorry, what am I doing? The transformation was over there. There we go. X plus 1 over 2. That becomes negative 2 to 2. And then you get, what do you get? 1. Is that right? That should be right. Negative 3 to 1. Let's check. So if I go now from negative 3 to 1, yeah. Okay, so the transformation that was given to us, we now know that's the transformation that we're working with, and that deals with the domain. And you can see that as you apply the domain into that, if you replace it, you get -1 to 1, -2 to 2, and then -3 to 1. If you found the integration for it, it should equal to 1. On a visual aspect, that means I can reduce this graph to 0, -3 to 1. That's what the graph would look like. So in that transformation. So you can see that to the left and then compression as well. Okay? And that should give you, let's go, menu 6 maximum. You can actually then work out the domain if they're asked domain and range question as well. So we can see at 1.375, or another way to calculate it is you can work out the derivative and find the derivative of the function. Now, last question. How do you find the probability density function if you have this transformation, 2x minus 1? So we've got the intervals now. So we started off with function f of x is equal to 3 over 4 minus 3 over 4x squared between -1 to 1. Everywhere else is 0. How do you convert this if we've got now f of 2x minus 1? They're asking what function. So we worked out the domain. Domain was -3 to 1. How do you work this one out? Find the rule. Find the rule. Just a note, if you weren't listening in this part, it is optional. There aren't questions on it, mainly because it's not on your study design, so not required by your study design. But it is just a nice thing to know, okay? And it's a very simple idea. I know they use different letters and all that, but this is just simply cumulative. So we know cumulative means area from left to right, it adds up, right? Since it's a probability density function, that means you'll always start at 0 and you work towards, thanks team, you work towards 1. That's the cumulative. So what you can see over here is the cumulative graph, is what your function generally looks like. You can go from 0 and then it increases to 1. So it means it's always increasing. It's a non-decreasing function. That's just one of the properties. Why is it useful? Sometimes, because you know it's cumulative. When you say f of c in a cumulative function, so f of a certain value in a cumulative density function, and it's equal to 0.5, what you're saying is that everything up until that value adds up to 0.5. That's just useful to know. It's like finding the median. You get me? So if you're working from left to right, it's just nice from reading the graph that if you knew f of whatever that value is and it's 0.5, it just tells you the density, the area tells you the probability up until that point. That's just the nice thing. So, but you just have to switch your thinking that it's a cumulative. That's the only difference. Okay? So when you're answering these questions here, so for example, this one, X seconds that it takes a student to complete a puzzle is a random variable with density function given by, so here's my function. They're asking, find f of x, the cumulative distribution function. So they're just asking you now, well, I've got a function that's probability density function. What would it be? What's the function if it's cumulative? The cumulative just has some nice interpretations to it. So here, how do you do the cumulative? Well, you got to add them. True, it's the sum of all the areas up to a certain point. So what you can see is this graph, 5 on x squared is technically a truncus function. You're saying that from 5 onwards, so greater than or equal to 5, so from 5 onwards, this area should be 1. Elsewhere, everything less than 5 should be 0. So if I were to change it, based on what I've understood, cumulative frequency is from negative infinity to the area under the curve, right? So here, I can already say from negative infinity up until less than 5, when x is less than 5, okay, it should be 0, because that would just give you 0. Whereas this one, x greater than or equal to 5, well then the area must be starting from 5 up until infinity of your 5 over x squared, but in this case it's the function of t, okay, just so that you can write the variable capital F of capital X. And you can see that from here this was pretty easy. This was just 0 for less than 5, and all you have to do now is integrate this one. So let's work it out. What's the integration of 5 on t squared? Or antiderivative? What's antiderivative of 5 on t squared? What does that give you? Who wants to have a go? This is just some basic chapter 11 stuff. It's 5 on t squared. What does it give me? Does it help if I rewrite it as 5t negative 2? Worried about your integration at the moment. No one has a clue. Let's go Noah. I haven't chosen you yet. What's the antiderivative of 5t to the negative 2? This one. 5t negative 2. Antiderive that for me. 5 on t? Yep. Good. Good. There we go. Negative 5 on t. Very good. And then you just sub in x and 5. So we get what? Negative 5x minus negative 5 over 5. That works out to be negative 5 on x plus 1, which is the same thing as saying x minus 5 on x. There we go. And that is your function for cumulative. So that means when you say capital F of 6, you sub into that function, that should give you the cumulative area under that curve. And that's just useful to know. So if you want to find a median, you know that F of that has to equal to 0.5. That's essentially it. Okay? All right, team, so this is a nice to know. Remember, it's just the way you interpret the function. The function represents cumulative. Okay, it means that it slowly adds up from 0 up until maximum of 1. Okay? I'm going to stop the video.